Okay, anyways, we just start for today. Okay, for today, right, we are going to be focusing on alkanes questions. Okay, but I know the notes, we got one small portion left. We finish that first in like 10 minutes. Then the rest of the lesson, we are literally just doing tutorial questions. Okay, we go through content, don't do questions, it's a bit pointless, especially for organic chem. Okay, so take out the tutorial. We're going to try to milk as much questions as we can today. Okay, and then next week onwards, we're going to move on to alkenes really. Similar idea, but just a bit more developed. All right. Okay, so take out your tutorial, but take out your notes first because I know the notes, right? We left with like the 2 more pages or so, 3 more pages. Yeah, okay. Then once we finish that, okay, then we can start on the new stuff. Okay. Paper, yes. Sorry. Not color, not color. What really? Define chemicals. Wow. Right. Okay, let's start for today. Okay, so can you guys turn over to page 21? Okay, last lesson, let me just do a quick recap of what we did. Alkanes in general, we did the mechanism. Can you remember what's the name of the mechanism? 3 words? Yes, okay, free radical sub or FRS for short. Okay, so we looked at the mechanism. I'm not going to recap the mechanism here because later we're going to do the question. Okay, but in other words, this is like the only reaction that alkanes can undergo, which implies that alkanes themselves are very unreactive, right? Okay, they can't undergo many reactions. Okay, can you remember just a few basic terms? Alkanes are generally described as what kind of compound? It's like S. Stable, yes, okay, but we are looking for saturated, yes. Okay, so a saturated compound, remember what's the meaning? The carbon atom around it can hold a maximum of 4 atoms. Okay, maximum of 4. Okay, around carbon. Again, carbon must hold 4 bonds, but depending on the type of bonds, right, you can hold different number of atoms. So on and so forth. Okay, but the other stuff is basically the mechanism. Okay, not much to recap there. I want you guys to turn over to page 21, right? Okay, let's look at the rate of free radical sub. Okay, FRS can be different rates, right? Depending on the type of halogen used. Okay, I want you guys to just look at the observations. Based on the observations, can you tell me which one's the fastest? Which halogen? Okay, fluorine. Yes. Okay, so fluorine is the fastest. And as you can see, right, when you go down the group, iodine ends up being the slowest. So there's a trend. Going down the group, the rate of FRS actually decreases. Our job here today is to figure out why. So let's lay down a few facts first. This portion honestly very, very small and not too important in the grand scheme of things. They don't test that often also. You must really need to know. Let's take note of this. The rate of FRS is dependent on just one thing. You know this thing, right? Okay, just link back to this idea. Okay, rate of FRS is dependent on how exothermic the propagation step is. So remember, FRS got 3 stages. Got your initiation, propagation, and finally, what's the final stage? Initiation, propagation, and termination. Yes. Okay. So remember, we are actually the most of the reaction actually happens in propagation. Why do we focus on propagation? Why don't we look at the others? It's because propagation, what's happening during the propagation stage. Okay, because it keeps regenerating the radical, right? And as a result, most of the reaction, like 90% of FRS, right, is your propagation step because it keeps repeating itself. Termination very fast. The moment the reaction finishes, really, then just react one time. Okay, then initiation, right, it's only at the beginning. That's why it doesn't take up most of the reaction. So in other words, we are just focusing on the propagation step. In other words, the more exothermic the propagation step, the higher the FRS rate. That's pretty much it. Okay, and if you take a look at the propagation step printed in the notes, right? Okay, let me just quickly write down first. Okay, if you look at the small little technicalities, right? Okay, you will notice that this is how the propagation step works. Okay, remember this. Can you remember the rules for propagation step? How do you know how to craft a propagation step? It's always 1, 1 with 1, 1. Okay. 1 radical and 1 normal particle. As you can see, it is what we are doing over here, right? Okay, and this is a very simple propagation step. Okay, regeneration of catalyst and whatnot. So we are looking at the delta H, how exothermic this entire propagation step is. So let me just explain what's in the notes first. How do you find the enthalpy change of this first step? What is enthalpy change in general? What's the formula? Enthalpy change is always bonds broken minus bonds formed. Okay, so I want you guys to just look at this. What are the bonds broken in the first stage? Okay, yes, the CH bond is broken. And what is formed? Yes, okay, HCl. In other words, I'm not going to write HCl, I'm just going to write HX, okay, because we depend on different halogens here. Okay, second stage, very quickly, just look through this. What is broken? Okay, the halogen bond, yes, XX, and then the bond that is formed is Cl or just CX in general. So if you notice, okay, if you want to find the enthalpy change of the entire propagation step, you just, how do you find that? Add up both enthalpy 1 and enthalpy 2. That's it, right? Okay, so if you have energetic stuff, so you notice, okay, you have a lot of different variables here. Depending on the halogen, right? You all see, right? This one is a constant, this one will always stay the same. But your halogen different, right? This one will affect, this one affected, this one also affected. So what exactly are we looking at, right? Okay, at the bottom of that page, they also will tell you guys. You just need to look, right, at how strong the HX bond is. Okay, the HX bond, right, has the biggest impact, right, on the enthalpy change of the propagation step. So in other words, you guys just need to be focusing on the bond strength of HX. Okay, so far, right? So guys, what's going to happen is this, because we are only focusing on HX, you can take, you don't need care about other halogen bonds. So we have HF, HCl, HBr, and HI. Now, first of all, what do you think is the strongest bond out of the four? Chem bonding concept. The strongest is HF because why? Okay, correct. F happens to be the smallest atom, and the smallest atom will overlap the most effectively. So yes, okay, HF bond, right, is the strongest. And then as you go down, okay, very obviously, the bond becomes weaker and weaker. So HI bond is the weakest. So in other words, what's going to happen is this, because HF bond is so strong, the enthalpy change of the propagation step is very exothermic. And that's why when you use fluorine, it is the fastest. Okay, so that's like the explanation for this portion. Okay? Okay, but then as you go down the group, what happens to the bond? The bond starts to become not as strong, right? Okay, it starts to become weaker, and that's why when you go down the group, what happens to the rate of the reaction? It becomes slower. Okay, because the enthalpy change starts to become less exothermic. That's why it becomes slower. Now, take a look at HI. I want you all to look at the table again. What's the observation that you all see for HI? Okay, it doesn't even happen. It's not even that it's slow then. It just doesn't work. Okay, why does FRS not work for HI? You all see there's a question at the bottom of that page. Okay, let's write this down. Why does HI not work? Okay, because guys, you can go and perform all your calculations. Let me just tell you guys one thing here. For fluorine, chlorine, and bromine, this is going to be the enthalpy change. Okay, the values are not exact, but it's something like that. Okay, so just take a look at these values. Okay, they are not exactly the correct values, okay, but it's something like that. Okay, this is the enthalpy change. Can you all see what is happening for iodine in particular? The enthalpy change of the propagation step is endothermic. It is the only endothermic reaction. So as you can see, it's the only one that doesn't happen. So how do you write down the answer for this? First of all, you must say the HI bond is too weak, right? And as a result, because of that, overall enthalpy change ends up endothermic. Okay, so HI bond is too weak. Thus, the delta H of the propagation step is endothermic, so it doesn't actually happen. So as I mentioned, I know halogen got different bonds, got like the FF bond, okay, the CL bond and whatnot. Okay, but we're only looking at HX. Okay, so it's endothermic, thus it doesn't happen. Okay, so that's that. Okay, so that's our rate of FRS. This one again a very small segment. In the grand scheme of things, again, based on how many years I've been doing this, again, this part here, not too common in open-ended, but more common in MCQ. Okay, so you just need to remember who's the fastest, who's the slowest, and the factor that affects it. Okay, can so far? Okay, there's this one small question, right? Okay, that we can consider as well. Okay, we shall think about this as well. Right? Okay, turn over to the next page, okay, page 22. Okay, read the question first. Okay, any questions? All good? Yeah. Okay, so this question here, right, they said, why is initiation not the rate determining step? Okay, so that's what we're trying to answer. Okay, so let's break this down slowly. Can you tell me what is the initiation step? What is involved in that step? Okay, forming a radical, how? What does it actually do in that step? Okay, what happens to that bond? The bond is broken, right? The bond in X2 is broken. So in other words, the XX bond is broken in the initiation step to generate radicals. Okay, but I'm more concerned with the bond breaking portion. Okay, so I want to explain this question, right, from the opposite perspective. They said it is not the slow step, right? But what happens if it is the slow step? Let's try to see what will happen. So if the initiation stage was the slow step, what do you think is going to happen here? Again, link back to the first thing that we identified. Initiation is all about breaking the XX bond. So if initiation is a slow step, right, that means the rate of the reaction is dependent on what? Okay, how strong the XX bond is, right? Okay, if the bond is stronger, does it take faster or slower? Okay, slower because harder to break, right? If the bond is weaker, it's faster. Okay, so let's just find out the bond strength of all the halogens. So this one you need to look at data booklet, but when you check data booklet, right, this is what you see. The bond strengths actually decreases as such. The strongest, for some reason, is fluorine, followed by, if I'm not wrong, is bromine. Yes, okay, bromine. Then F2, then finally weakest is I2. Okay, see this first up. This one is going to see all the values from data booklet. Then you go and compound everything together. Okay, see what we are doing. We take it as if initiation is a slow step. That means we must consider the bond strength of XX. Okay, so we list everything up. Now, if this was true, which one is the fastest reaction? Which halogen is the fastest? I2, because I2 happens to be the weakest. So I2 is the fastest. Who is the slowest? Cl2, because he has the strongest bond, right? But is this true in reality? Is this correct? Who is actually the fastest? Yes, again, the fastest has to be fluorine, right? Because fluorine looks at how exothermic the propagation step is. Can you see that? Okay, whereas the slowest, based on our observation, who is the slowest? Okay, I2. So can you all see, right? This doesn't correspond, right, to what actually happens in real life. So we actually investigate the wrong idea, and we can see that based on that, it just doesn't tally. So that's how we can answer this question. They never ask us to determine what actually is the slow step. Okay, that one is beyond our syllabus really. Okay, they only ask us why initiation isn't. Okay? Make sense? Right? Okay, I mean that's it. That's the end of alkanes really. Okay, content-wise, we are done. Okay, so remember last week we went through all the ratio of the different structures and whatnot. Okay, count the number of hydrogens. Okay, that's what we're going to be practicing today. Okay, and we'll start with a mechanism. Later we try one of those ratio questions. Then other than that, got other stuff as well. Okay? Any questions so far? Are you okay? You look very okay, so the final page of the notes is environmental effects. No one cares about that. It doesn't matter. You all learn this in secondary school. Right? Okay, photochemical smoke, whatever. Okay, this one doesn't matter. Okay, Earth is gonna die anyway. Right, what's the point? Okay, if no final questions, okay, you guys can take out your tutorial. Okay, let's just begin with that. Right? You feel like you're turning sick? Is that feeling, right? Okay. Go back to rest early. If you try to settle as much as you can today first. Right? Okay, come. Let's take a look at the tutorial. Okay, we're gonna start with level 1 questions. I want you all to take a look at question 2. Okay, we're gonna draw a mechanism, and it's similar to the one that we did in our notes. Okay. Remember the rules for initiation, propagation, and termination, and then we should be able to do this quite well. Okay, let me break down the question a bit for you guys first. Okay, then I'll let you guys try. Right? Okay, all good. All right, for question 2, they ask us, right? Dichloroethane can be made from ethane. Okay, so first of all, ethane is how many carbons? Okay, 2 carbons. Okay, good. So ethane has 2 carbons, CH3, CH3. And they ask us, right, to form dichloroethane. Now, first of all, what is dichloroethane? Okay, can we break down the name like what we did last lesson? When you read the name, you must read from where to where. Right to left, right? Okay, on the right hand side, what do you all see? Okay, I already see an ethane now, so this is quite straightforward. Okay, but what's dichloroethane? That means there are 2 chlorines substituted onto the ethane, right? Okay, but there's another problem. The 2 chlorines, how are you guys going to arrange? Should we arrange 2 chlorines on 1 carbon or 1 based on the name itself? Yes, it's on the same carbon. Okay, so in other words, what's the structure here? CH3, then okay, what do you have? C. How many Cl? 2, right? So then the last one will be what? It must be a H, yes. Okay, so you compare, guys. You are taking out 2 H's, so left with 1 H because the 2 H's have been swapped out for chlorines. It is not an overall equation. Again, I don't care about that. I care more about the mechanism. Okay, yes, let's get back to that. How do we know it's on the same carbon? What if you put it on 2 different carbons? So notice this, this ethane, right? Ethane, you can either put 2 chlorines on the same carbon or ethane you put on 1 each. Now take a look. How will you name this compound? Yes, 1,2-dichloroethane. You're interested in write this down also? Then this one is known as what? If you were to name this, don't look at the question. This is 1,1-dichloro. And sometimes 1,1 is a bit redundant, that's why they never specify. So if they want it to be on separate carbons, they have to specify. Okay, but this is also known as 1,1. But again, it's not really nice to say 1,1. Okay, can? So bear that in mind. Okay, again, if you want to draw skeletal formula, up to you. If you want to draw the structural, also up to you. Okay, from there, let's try the mechanism. Okay, I'll give you guys some time. Slowly go and try. Okay, or perhaps one last thing to break down first to make sure you're all on the same page. How many substitutions is this? Okay, clearly there are 2 substitutions, right? So remember, we in the notes that time also did a die substitution mechanism. Okay, you want to refer to that also can. Okay, but it's all about applying to this question. Okay, give you guys some time to try. Right, I'll walk around and then just help you guys along. try not to just directly copy from the notes. Okay, just remember the rules first. Okay, then from there give it a try without copying directly. Yeah. Okay. Remember, this is a die substitution we are. Okay, so substitute twice, but you don't do it at once. Rubbish. I already. All right, now you can. No, initiation is just what you create immediately can. Yeah, because last lesson we talked about how the initiation step is only a little bit of UV light. So you don't need to do twice. Everything is mostly the propagations. You got to put two chlorines. The more you put one, then you want to put one already. You want to do next. You remove the chlorine. You can think of it as a set. This is one set, this is another set. This right will follow exactly what we did over there. Here what you do. You got rid of one heat, right? That's why I call it so the same thing. You're just getting rid of one. CL must be stable. Because CL, right, you're trying to substitute CL. So you cannot substitute and remove the CL again. That's a bit. Also, yeah. You want to do once at one. Yes. Okay, that's correct. Okay, you need a population to all lump together, so you couldn't do that. Okay, but okay, let's see. Here you did another one. Right. Population don't need to do. The only two things is your propagation. Okay, the only population is for, but it's a propagation that you need to show twice because you're substituting twice. For termination, just choose the simplest free radicals and then combine them together. So you don't need to draw until like six configuration. I don't do like six in total, right? Yeah, but let's choose the easiest three. So maybe the first three are settled already. Okay, I don't actually. Any three one. Yes. Then you have three equations and two electrons come together to form a bond, right? So this one carbon two, carbon three. Yeah. Dot shouldn't be on because the hydrogen, right? We remove hydrogen, we remove from the okay, so come, let's go over this question. Okay, there are some small little details I need to talk about. Okay, first, initiation step. Now, initiation step is the only step, right, where you're required to write the arrows. Yeah, okay. So first of all, must check for UV light. Without UV light, this wouldn't even happen. Okay, go add that in. Okay, then afterwards, okay, you get two Cl radicals. Okay, remember the radical. Okay, the electron on the left, you point to the guy on the left. This guy on the point to the right. So like a bird. Okay, remember this bird formation. Okay, then later on, right, towards the end of the lesson, if you got time, we're gonna learn the arrows for both propagation and termination step as well. Okay, but anyways, okay, the second one is this. Whenever there's a multi-substitution, you just need to repeat the propagation step, not initiation, not termination. Okay, so for propagation step, I'm going to substitute once first. You cannot substitute twice at the same time. Okay, so this is a normal particle react with a radical. Okay, most of you guys got this. Okay, so just bear that in mind. Now you look at this first step. You're turning this into a radical, right? By removing a H. Look at the position of the dot. I want you guys to put the dot on the carbon now. Don't put it at the top right anymore. Okay, because you are removing a bond from carbon. Dry hand technique. Never seen before. Okay, so yes, you must remove from carbon. So carbon has now the radical. Then you can form HCl byproduct. Okay, then afterwards, okay, of course, repeat this. You're going to repeat this for your Cl2, and you can get the first substituted product. So take a look at this. This is considered one set. Okay, so I'm going to divide this up. This is one set. Okay, you want to substitute once, you need two propagation steps. So if you want to substitute twice, you will have four propagation steps. All got it? Now, you have to follow the pattern. So some of you guys struggle at the third step. Because what y'all did is you're going to remove the chlorine. But take note, you want to substitute two chlorine. So don't get put already, then remove. Okay, so go and do the same thing as what you see at the start. Copy and paste. You remove one H. Here you also remove one H. And again, I want you guys to put the dot on where? The C. Don't go and add any Cl yet. Okay, so notice, okay, I'm always following patterns from the first step. Okay. Next, okay, just take the final, that guy over there, react it with a normal compound, which is Cl2. Just copy and paste from what we did over here. And then you can fill this up with your Cl. So it becomes CH2Cl2 plus Cl radical. So you're repeating the propagation process 2 times like this. Okay, so those separated. Okay, then for termination, right, I don't think this is very difficult. Combine any two radicals together. As long as we got 3 equations, we should be safe. Okay, I know here got more than that. Okay, so Cl plus Cl give you Cl2. Okay, Cl plus the other radical will give you CH3, CH2, Cl. There's another way you can form this product okay, in the termination step as well. Finally, I have the two alkyl products, two alkyl radicals, right? So what's this structure? How am I gonna get? Okay, CH3. You are basically forming remember this one is what I talked about, right? One of the products in the termination step will be what? Compared to the starting reactant. Yes, the starting reactant is 2 carbon, this ethane. This one of the byproducts can be double in size. Butane. Okay, then. Okay, let's discuss the second part together. Okay, I don't think there's any more issues to talk about here. Okay, for the second part, they ask us to suggest the byproduct of this reaction. So you can mention where the byproducts. Okay, byproduct is. Okay, HCl is one, definitely. Okay, but you see, termination is all the byproducts. Right, okay, especially this guy, right? Okay, so then they ask us, right, explain how it may be separated from dichloroethane. Okay, think about this question, guys. Let's go through this together. Okay, pick out one of the byproducts first. Okay, should we pick fluorine? Because they asked us how to separate this guy. That means this guy, right, is going to be mixed up, right, with your product. But chlorine is a what? It's a gas, so it's going to fly away itself, right? Okay, so let's not pick fluorine lah. Okay, this one is your part of your product. Okay, so you can pick this. Or you can even pick this. Okay, anyone works. Now, the thing is, they want us to separate from that, right? Okay. Are there some separation techniques that you guys can remember? Sorry? Fracking, that's a oil, that was in oil, fossil fuels, blah, blah, blah. Okay, now it's just a normal lab experiment. Okay. Fractional what? Yes. Okay, guys, this is one of the best ways, right, to separate organic compounds, or any compounds, in fact. Okay. Now, distillation, you don't write the word fractional, is fine. Okay, distillation in general. Why? What property does distillation capitalize on that allows you to separate stuff? Yes, not density, boiling point. Yes. Okay, so fractional distillation or just distillation in general, right, takes advantage of different boiling points. Okay, so that means who is the guy that ends up evaporating first? The compound with the what? Lower boiling point, yeah, that one you all know already, right? Okay, so yeah, okay, so how do we explain this question? Now, it's because, guys, how do you know that, let's say I pick the final compound, the one with 4 carbons. How do I know that this guy and the other one, dichloroethane, how do I know that they have different boiling points? Okay. Is it about chain? Okay, guys, let's just say this becomes a boiling point question. And they ask you guys to tell me to predict which one has the higher boiling point. How will you explain this question? Yes, pretty much all of that chem bonding stuff. Now, this question just suggests one byproduct, that's your 1 mark. And then afterwards, how it may be separated, give me the method first. And then tell me why the method works. It's because they have different boiling points. Can already. Okay, but let's go a little bit deeper. Let's discuss this one more time. How do you predict different boiling points? You must always compare what first? What's the main overarching factor? Yes, in the size of the electron cloud. Okay, we use electron cloud, not just molecule. Electron cloud size should be the first thing that you compare whenever you want to compare different boiling points. Okay, so that one is part of another, maybe they can ask another third part of the question. They ask you predict who has a higher boiling point, something like that. Okay, so that's mechanism done now. Okay, we're gonna move on to other types of questions. Okay, start to do something a bit more challenging also. Okay, so any questions? Yeah, good enough. Yes. Yep, for the butane, yes. As long as it's different from the dichloroethane, chlorine, try not to use this because it can fly away. Okay, now let's look at question 5 once you're done with this. Okay, because the point of this question is to bring out distillation, the fact that we capitalize on different boiling points. Okay, question 5 is one of those ratio questions we did last lesson. Okay, so give it a try. Okay, they tell you the name of a compound. You must go and draw out the compound first. And again, I suggest drawing schedule. Right? Pentagon. What's a pentagon? See, sometimes you use the shapes. Pentagon, right? Then like hexane is just hexagonal. Yeah, I know some people struggle with drawing pentagons. I used to struggle with that also. Okay, so all that teach this but no. Okay, because pentagon, right, is a bit asymmetrical, so I understand why it's hard. Yes, but it looks like a house. Yeah, 5. It's a house. Okay, but for me, right, I'll make the house a bit bent like that. And okay, now the worst one is I tell you guys got a heptagon, 7 sides. That one even to today I will struggle. That's damn difficult. Because hexagon is symmetrical, right? Hexagon everyone know how to draw. Because you all end up drawing benzene in a few topics time. Yeah, but heptagon, I still struggle. I don't know how to draw 7 sides. Very difficult. Yeah, remember these are two things you need to do. First, draw out all the structures, all the unique structures. Then later you worry about the ratio.
Wait, why am I worried for this?
Yes. Usually they come together. If they ask you to draw the structure, they confirm ask for the ratio. Yes. Wait, yes, you're supposed to sum all the possible places where you can sum the CL. Okay, they want all the possible structures where you can sum a CL. So remember, what's the criteria? As long as the carbon has a what, then you just substitute CL. As long as the carbon has a free radical site, hydrogen, yeah. Again, you're trying to substitute H with a halogen. Because there are 4 possible places to sum.
Is it my home
Okay, guys, you have to realize something. When it comes to the products, I want you all to number out the original compound first. Don't go straight to drawing the products. Okay, remember what we did last week? I number the 1, 2, 3, 4. You're supposed to get 4 max. I cannot have 5 because they say only got 4. Right? And then, of course, any duplicates, you use your 1A, 2A, that kind of thing. Sorry? You're supposed to draw 4 structures of 1 chlorine, yes. Okay, so they say monochlorinated. They will, this kind of questions always monochlorinated, right? Okay, so now you guys figure out the structure already. Okay, once you identify 4 structures, you're going to draw all 4. That one not very difficult. Okay, then later when you put them side by side, you look at the ratio. Yeah, maybe people miss out. Okay, go and check. As long as the carbon got H, you consider that. Only carbon no H.
So is that so awkward thing?
Yeah, it's fine. It's normal. It's awkward to you guys because you never see before.
Maybe.
What? Okay.
Okay.
Or you just put A2Cl together, or you write on the line. Yeah.
It's not just for you. This way.
Everywhere you can think of 4 factors at M. You get 5, 6, at least the factor more. Remember, the ratio is all a game of probability. Okay, out of all the hydrogens there are, how many can give you that particular product? The first 2 are correct, the last 2 at the bottom are not correct. This one and this one are the same. Yeah, feel my head, right? You feel your head is feel. Feels right. My find the flavor.
But is it a plain girl? Like, oh,
Left and right is no, right? Right hand side or what hand? Yes.
Isn't that ratio? Ratio is how many?
Yep.
How many overall? Maybe now over here the ratio has.
My God, yes.
Initially there were 3. 3 there. Huh? Okay. What is the
Okay, it's all a game of chance. Yeah. From the start of organic chem, right, I can usually tell who is better at organic than physical chem one. Do that Azealia, for example, going organic. Really, O-level, hard really. Okay, remember guys, let me show you all a few techniques. Later draw in random looking ugly structures, right, for you to practice. They are not in the notes. Okay, so every time you all have a structure, I want you guys to find a symmetry. Okay, guys, every time you all see a structure, please find a plane of symmetry. So in this case, I purposely put my methyl group at the top so they look very nice, right? It looks very symmetrical. So I need you guys to split this up into half just like that. And after you split it into half, I want you guys to number all the possible places. Okay, we start off at the top here. Okay, remember, any carbons that are on the line, right, that you just cut, it will still be counted, by the way. Don't forget, even when you cut through. Does this carbon have a hydrogen? Answer is yes, just put one there. Does this carbon have a hydrogen? Have. A lot of people miss out on this part because just forget that this is a carbon, so 2. We go down. Here have 3, 4. Now, can we go to 5? As you can see now, guys, the technique is this. Once you draw a line of symmetry, anything past that border is a duplicate. So over here, this is a duplicate of what? Tell me. 3. Yes, okay, it's a mirror, right? The legit looks very symmetrical. Then this is 4. Okay, number all your duplicates as well. That's very important. Okay, from there you can already get your 4 structures. Okay, so let's just draw very slowly. 1, so you just attach a Cl to 1. 2, you attach a Cl to 2. 3 and 4 likewise. Okay, so the key to identifying duplicates is to find a line of symmetry. Once you have done that, everything past that line you ignore. Okay, later there will be other questions now. Okay, from here, the ratio part, some of you guys are struggling with it. Okay, come take a look first. Your job is to ask yourself, each carbon 1, 2, 3, and 4, how many hydrogens there are? So go and look at number 1. How many hydrogens are there on carbon 1? How many hydrogens for carbon 1? 3. 3 invisible hydrogens, so 3 lah, that's the answer. How many hydrogens are there on 2? Just that 1, 2 lah, so 1. Very low chance of substituting, so very low number. Can see that? Carbon 3, how many carbons? How many hydrogens, sorry? Okay, it has 2, right? So it's answer 2. We have to look at our diagram. You have to account for all the possible duplicates. So since there are 2 of the carbon trees, you just take 2 times 2 give you 4. Same thing for carbon 4, also got 2 hydrogens, but you must times 2, so you get 4 also. So answer 3, 1, 4, 4. Okay, because currently how many bonds do you see? Can you visually see? 3 bonds are carbon has how many bonds? So that 1 invisible has to be 1 hydrogen. Same thing over here. Look at carbon 1. How many bonds can you see are there on this carbon? You only see 1. That means there are 3 invisible hydrogens. Yeah. Okay. Can? Some takes a bit of practice. Okay, but once you get used to it, very fast. Right? We'll do something similar as well. Okay. So once you guys are done, I want you guys to take a look at. Let's see. Okay. Any questions so far? Okay, those who are done, turn over to question 7, it's the MCQ. Okay. Following first. So that I think numbering very important. Okay. Last lesson I went through out of 10 out of don't know what, right? Out of the total. So that was just gonna make it a bit harder. Okay, so you know this, just remove that already. Just count the number and then the number just write as your answer. Can already. Because they ask for ratio. They never ask for fraction. Okay. In the meantime, those who are done, just take a look at question 7. Right? Yep. Freaking sticker on your watermark. If you are not, it doesn't look like a Korean. Would you print it out and then the face it? No, right? You think it's somewhere, right? Oh my God. Like, oh God, I need right now. Oh. Well, you like calling what out? The rest, if we once you get an answer, you want to try, right? You can try the next page, question one. Because I will spoil it out. Just give you guys a bit of a hint. Question 7, right? You all see, they ask for bipolar, you'll be like, what bipolar? Then you look at all the options. In what world, what the hell is happening? Can you all just tell me what's happening first? What are they attempting to do here? Combining, okay, where do you think, which stage can you possibly see these guys appearing? Termination, because as I mentioned just now, termination, there's one very special step, right? What happens? You can double up the original alkane. Can see that? Okay, so in other words, when we look at this question, I need you guys to first identify the radical. Now the radical doesn't matter where because all the 5 carbons are the same. So you just have to draw one dot on one of them, right? So we know that in this question, they are specifically referring to the termination step because it involves 2 of these alkyl radicals combining. So in other words, your job here is just to draw these 2 guys combining. So which option will you get if you try to draw these 2 guys combining? Okay, just say what answers do you think? Okay, there's some A's, I heard a D just now. Okay, it should be D. This question, I think some of you all see, there's only one trick to it. Why is the rest wrong? Okay, there's no line. Yeah. Okay, guys, you all see, when 2 of these radicals combine, these 2 dots must form a what? Bond. Okay, you must form a bond. So you all notice, you need to have this little bridge over here. Okay, this is the bond. Okay, you must have a bridge between the 2 compounds. You look at the rest, they are kissing each other. Bro, no, okay, cannot kiss each other. You need to have space in between. Okay, so cannot kiss each other. This one all the more cannot. So why they all having a threesome? Okay, cannot. Okay, so they must have a bond in between. Make sense? Okay. Next time you'll see this question, that's the only trick. All good? Okay, with that said, go and look at the next page question on the right hand side. Question 1. Again, level up question 1. Okay, yeah, pretty much. Okay, guys, what's fission? Don't know what's the opposite of fission. Fusion. Fusion is what? You all know what fusion means, right? Combine. Fission means break. Okay, so fission means break. Homolytic means what? Okay, is the which arrow that we learn 2 arrows, right? The half hook arrow or the full arrow. Homolytic is which one? The half. Okay, so take note. The half-headed arrow is homolytic fission. Then this one is heterolytic. We only learn heterolytic in the next chapter onwards. Yeah, you look at the structure first. Okay, the options try best, okay, but it's just the structure. Remember what we talked about just now. Okay. Okay, guys, one thing I think that's a typo. Can you all check? They said compound R should be C14H26. Okay, this compound R should be C14H26, not 28. There's a typo. Can? Right? Yeah. Then other than that, should be fine. It's a bit more challenging. That's why the level up question already. Okay, so let's go through this. Okay, I won't show you the answer yet. Okay, but I want you to break down the first statement. Okay, option A, they ask us maximum number of monochlorinated products is 5 products. You have to get the 1, 2, 3, 4, 5 lah. Okay, cannot go more than that. Any 1A, 2A, that was apart, separate. Okay, can? So look at this structure here. Again, what's the technique we need to do to determine the number of unique products? Find a line of symmetry. You can already see you can cut this guy into half. Don't care about the rest. Look at only one side. Okay, but then okay, look at this first. Agree the first line. Now, if you look at the one half, ignore the other half, right? Is there any point at which it can be symmetrical also? Where? The hexagon could be symmetrical, but it's not anywhere. It has to be along this part here. You can see that? You tilt your head, okay, then that means both sides of this hexagon is symmetrical. So this question has 2 lines of symmetry. So you look at the left side, but you only look at the top half of the left side. You can see that. So I basically shrunk the molecule. Okay? Now we start numbering. Okay, let me just start at where the line is. Here is 1, right? Okay, then keep going. Okay, go 2, then 3, 4, 5. Do I go anymore? Okay, don't go past the line. See, I never went past any line over here. You're on the line now, but don't go past it. Okay, this is the duplicate of what? Okay, you must show the line in order to know it's a duplicate of 2, so it's 2A. Then this one is 3A. You have to tilt your head along the line, there you can see. Okay, can? Okay, so it's fine. So A is correct. But I have to go through why the rest are wrong. Okay, let's think about it also. Okay, remember change this C14H26 as a typo in the question. Okay. Okay, so how do you think this product is going to form? C28H. Big compound. Very big compound. How do you think this is formed? Okay, why do you know it's in the termination step? Okay, because initially we started off with 14 carbons, somehow it can double, right? Okay, and that can only happen in the termination step. So isn't this correct? Right? Okay, it's because the molecular formula here is wrong. But how are we going to check? Are you telling me you're going to draw 52 hydrogens and go and count them? No, right? Okay, so let's start off with something a bit more simple. We go to the simplest, which is CH4. Now, what's the radical form when you do CH4? CH3 lah, right? Okay, so we don't draw the whole mechanism, but CH3. Termination step. How do you double up this compound? CH3, CH3. What do you get? Okay, C2H6. Now guys, you starting compound, double up compound. What are you doing here? From CH4 to C2H6. What happened to the carbons? Carbon double, yes, but do you double the hydrogens? No, you have to double and -2, because that's what you did over here. You -1 each, that's why you -2. So guys, can you tell me what's the correct answer over here? Yes. You double this guy, but then you -2 for hydrogen. Double -2. So 52 -2 is 50. It's not 50. Know the pattern. Can see how the pattern works. You see, in organic chem, it's like that. I don't have time. No one has time to do it 14 and 28. But we do have time to quickly deal with a 1 carbon. If 1 double up to 2, it's going to follow the same pattern no matter how big the compound is. Okay? Gemma, you okay? Yeah, yeah. Okay, guys, as we mentioned, third option, fission means break. Yeah, okay, break bonds. Homolytic means the single arrow. Okay, and basically our FRS is the only one with this single arrow, right? So, okay. That's not the point of this question. The point of this question is, do we break bonds only in the initiation step? The weird word here is only. Okay, usually this kind of absolute statements may be wrong, but we need to check. Okay, how do we, okay, initiation step, do we have homolytic fission? Definitely, right? You are doing this third little thing here, right? Okay, you're breaking bonds homolytically. Can? Okay, but in the propagation step, is this same thing gonna happen? It is I, it is P. Okay, let's just do the smallest one. I don't have time for that. Okay, we do the smallest one. Okay, so what's the propagation step again? Okay, take your normal, react with the radical Cl to form and HCl. Okay, the one H come out to form the Cl. That's the first stage. Second stage, react with normal, which is your Cl2, in order to get the final product, plus. Okay, you look at propagation step, right? Is there any homolytic fission, any breaking of bonds? Look closely. Okay, Cl2, yes. Yeah, that's the answer. But is it just Cl2 that's breaking? Anything else? CH bond is broken, Cl2 is also broken in the propagation step. So that means, guys, it doesn't just only happen in propagation. Go write the initiation, sorry. Go write down propagation 2. Yeah, you're gonna make a radical, right? You break bonds also. Yeah. How about termination? Have or not? Termination is all about what? Combining, which means bonds are being formed. So what do we call that? What's the legit term? Homolytic fusion. We don't really see the word homolytic fusion that much, but just know bonds are formed in the termination step. So there's no breaking in termination. Okay, can? So that's like 2 is wrong, 3 is wrong as well. Okay, guys, final option. HCl form in the termination step. Why wrong? Exactly. Okay, good. Because you see, termination is about combining of radicals. If HCl was formed, it means you had a H radical and a Cl radical. But there's no such thing as a H radical. Go write that down. No H radical. Never learned before. See, what MCQ can do a lot of things. Okay, but before we take a break, let's not do other questions first. Okay, before I take a break, I'm going to show you guys wacky structures. You can draw it out somewhere. Okay. Okay, so I have one structure. I have one structure there already. Okay, let's take a look at the rest. Right. So, okay. See if I remember. Okay, one please. Like a stick man. Okay, your job is to tell me how many possible structures. Up there, let's try. Run is shouting. Is it run is alright? Oh, run. Hey, come on! I can't do Chinese. Can't write. I can still speak. Second knuckle. I don't know what cabbage was in Chinese. Yeah, I tell the uncle, why not the菜? Then there's like 3 vegetables there. 白菜. I mean, huh? No, I know. 番茄. Wow, not bad, right? Okay, I think only know food. Now we're not doing any new question. We're just look at this guy. Okay, look at that dude there, right? And then just tell me how many structures he can form. Okay, just now this guy you identify 5. I want to do the same thing for this dude. Okay. Try to think of another structure. Yeah, I'm gonna draw another structure.
Wait, 5 more.
Oh shit. Very shit. You the one click. Okay, do the one on the left first. Okay, don't look at the right one yet. No, looks crazy. Oh shit!
Yeah.
Dude, there's a freaking school in Singapore that called swastika, bro. Great swastika, they will actually cancel. Cancel. Oh, Tokyo very sure that I gave up on the second episode. Too boring. Singapore is an opposite hospital. Hospital. The A-name hospital. It's called Ray Swastika Primary School. Yeah, there's a PSLG, right? So it's oh, that one a bit trash. Yeah. All the gangster, all the police car really appeared. Yeah. Okay, go and cut the structure, cut this, cut that. Okay, go and just tell me any unique structures. Definitely not one, definitely not one. How many unique monochlorinated products? For this question, we got 5 because I found symmetry and I count. Right? Okay, don't you show me what ratio. Right? Number of products. But you need to find any lines of symmetry. Okay, that's number 1. Right? Yes. You have 7. Okay, never mind, just write down your answer. Okay, whatever answer you write, just write down. Okay, I go through this, then we can try the same thing for the next structure. Okay. First of all, guys, find any symmetry because you don't want to be looking at like 15 different carbons there. Okay, where is any line of symmetry? Okay, not really sure. You all see, okay, maybe I ask another question. Find a center. Where's the center of this molecule? This thing here. Can see that? Okay, so I can cut it like that, right? Into 3 different quadrants. Can see that? Okay, it's not really a line of symmetry. Sometimes I can tell you guys, instead of finding a symmetrical point, I want you guys to find a center point also. Okay, and the center point just go and divide the compound into 3 different portions. You all look at each other like, funny. Look at it, I saw the look of despair in eyes, like, wow. But guys, actually, you see, it's quite fun, right? It's not as boring as like chem bonding, right? Come on. Admit that this is not as boring as that shit. Okay, I cut it into 3 portions. Can see that? Okay, so I cut pizza, I cut into 3 parts, but I only have 1 part that you look at. Agree? Ignore the other 2. I look at this guy here. Within this guy, can I find any point of any middle point or whatever? Where? Okay, instead of drawing more lines, let me just highlight this middle here. Can you see that? So that's another middle point, right? Okay, so can I substitute on this guy? Can okay, there's a carbon, hydrogen there. Can this guy have? How about this guy? Yeah, this part of middle point. So imagine this last week I went through. Okay, this point can turn on. And when you turn it around, do you see it's the same? Yeah, okay, so this is a duplicate of 1, so it's 1A. Okay, 10, right? Okay, then any more? Remember, this carbon can? It is a unique carbon because there's a hydrogen on it, right? So the answer to this is 3 monochlorinated products. You ignore the rest really. No, the A and B is just for us to know that it's a duplicate of 1. Ah.
Just one and three, right?
Yeah.
You can split it in like three.
Oh, no, okay. When I flip these two bonds, this one and this one, I'm twisting this bond. This bond, I'm rotating it. Yeah, it's the same. You want to put the bottom here or put at the top, it's the same compound. Because they're both branching out into one carbon. So it's the same branch. Can you see that? They treat it as the same branch. Like you start from the center, and then you go smaller, right? And you realize it branches out even more. Okay, all good? Okay, let's work out the same thing for the next compound, guys. Okay, we roll this out together. How many monochlorinated products can I get for this structure? First, what should I do? Okay, look at the whole compound. Where's the line of symmetry? It's right smack in the middle, right? Apex. I don't know what that means. Okay, so yeah, can you see that? Okay, cut it in the middle first. So I don't care about right hand side. Ignore the right hand side totally. Okay, guys, let's start at the left hand side. Any smaller symmetry that we can find? Any center points that I can find? No, really? Line across. Okay, you all realize when I come here, this is another center point. Because this one is branch have two carbon, branch have two carbon, branch have two carbon. It's like same over here, but the branch only has so many carbons. Branch one carbon, branch one carbon. Can you see that? Over here, I'm branching out two carbons, two carbons, two carbons. They're all the same. Purposely, I make it that way. Can you see that? So in other words, guys, you can ignore the other two branches really. It's the same. Is that okay? Okay, this one. Here. This one. Okay, I cut this first. Sorry. No, it is symmetrical along this line first, right? You see? Okay, cut it into half. This one's not exactly called symmetrical. It's more of like you find a center point. Because in this center point, right, you go whatever direction, you'll always be the same. Can see that? So guys, maybe to phrase things a bit better, it's not just line of symmetry. Sometimes there's line of symmetry, like here and here. But this one is more or less just a middle point. When you stand in the middle, you have three different options, and you realize all options are the same. Imagine you're standing there, you want to walk in three different directions. But all the same one. So you only look at one of them. Can you see that? You ignore the other two pathways. Why will we walk the same pathway twice? Correct? Okay, so imagine this, okay, we do center point from now on already. Okay, so I'm gonna look at this path. I'm gonna walk only on this path, right? Can I substitute here? So can I this one? Can? Here can? Are there any hydrogens here?
Oh no.
Okay, so there are no hydrogens here. Okay, any more? This one, remember, don't forget the carbon at the border also. Okay, so this is carbon. So I have three products. Okay, can we just identify all the duplicates also? Okay, this carbon here, the one that I'm pointing at, it's a duplicate of, okay, one, so it's a duplicate of one. This one, also one. Can see that they are walking the same path. Okay, you can call one B or whatever, I just call all one A, they are the same thing. And this one, 2A, A. The rest is pretty much the same over here. Okay, yeah, okay, so this one takes a while, I know at the start, okay, it's a bit confusing. Okay, but the moment you get this, eventually you'll be here. Okay. And right, okay, we take a short break. Okay, then later we try a few questions. Can I know, right? You guys, right? What? Okay, because some you all join at different times, I need to know what notes you all have, what notes you all don't have. Then I will go print everything straight for you guys, right? And then you have to go and look at the notes, study those topics again. Yeah, that's what I'm trying to do. Yeah, I'm going to list down all the topics because now I can go and print. Okay, because I want you all to work for you all then. Or you printed yourself instead. Okay, that will be. Okay, just tell me whatever I'm going to print, settle one. whatever you don't have in hard copy form. If not, I can just print everything. You don't want to print. Okay. Yeah. Don't know that my I'll just print everything. Whatever. Yeah.
And
Yeah, so I'll just mention first what I want you guys to do also. Because I know some of y'all missed out on certain topics. Like the very start, I think a lot of you guys missed out also. We'll be focusing on like one topic every week, right? I need y'all to go and fill up all the blanks in our notes. Our notes got all my notes got blanks on. Okay, the blanks you need to go and study. So when you study, right, you fill on the notes also. And then that's how you can get a bit of better understanding with the past few topics. Yeah, okay, because the thing is, I need to continue with the syllabus. And we have limited amount of time only. Okay, so this month is the only time I can pretty much see you guys, right? Okay, we have to do alkenes, preferably also arenes. Then that will be end of the year. Yeah. But then other than that, right? Okay, all these topics you still need to revise, but I mean you guys have to do it on your own. Okay, then like every week again, check progress.
I don't have issues. Oh, I don't have issues without.
Is there any more topics? Okay, yeah, I know some of you guys don't have a lot because your join not say very early also. I think more. Yeah, go ahead. What did I do? Okay, yeah, could be. After that, it's like as in intro to organic chem. Don't have already done. Yeah. Actually, you can just do now because I want to print now. I got kind of work for your. Yeah, just coming out.
Atomic.
Okay. Okay. So 222. Okay, and your this
One big one.
like quality order, like order, like okay, this one. Yeah, atomic structure who needs. Okay, all up. Okay, so chem bonding, I feel like some of the bonding. Like energetic, I pass. Okay, I see three of you guys separately. Okay, no matter 4 or whatever. Redox and stoic Q. Whatever. So 2. Which energetics I gave you guys? Very good. Okay. Sorry? So 3. Okay. The rest should have most of them. It's not definitely have already. Equilibrium. Pretty sure some of you don't have these, right? Kinetics, I feel like some of you don't have. So this should be settled.
I don't think that
You have kinetics. Okay. Yeah. Because yeah, because I just need to. We are gonna start every week. I need you guys to start filling up the notes. Because that's the only way to force you guys to like study back the topics. I don't have time to do the topics with you guys. Yeah.
You thought you're the summary of your.
That one really convert first. That one I need to convert to PDF. Actually, I can try lah. I don't think I can print it out yet because that one is exclusively online. Yeah, that's how I want to. Anyways, the notes pretty much the same thing. Okay, let's do it. Just print on this.
What's the text every time I went around here? That you are very we not used to it because that context.
But as I told you to tell me the topics that you read at, right? Yeah, just message, just get back to me on that. Because I'm doing bit by bit. Yeah. Okay. But the thing is, content-wise, I feel like your content is just not there yet. And the thing is, because you join late, then we also don't have time to catch up. Yeah, content, we can settle all our new topics first, which is what we're doing now. There's some old topics we still need to set. We have this slightly compromised version of how to catch up on that. Yeah, questions we can eventually do well on. That one need time. That one I must do with you guys. Yeah, that one we can settle. We will work on that. But as for content, I need you guys to do yourself because I don't have time for content with you guys. Yeah, it's just gonna get worse, more busy and more busy. Yeah. Yeah. It's not. Really, even man is you say eager. Oh, really? Okay, the thing is math, right, is very technical. There's very little application. You know what topic it is, very easy to identify. Chemistry is a lot more dynamic. There's a lot of questions they can test on. A lot. Yes, they can. And they can test weird stuff. So yeah, my J2 still the A-level people. This is hard. This was hard. So because I was hoping that last year's paper was very difficult, like out of the ordinary difficult. So I was hoping that this year they will tone it down. But apparently from the feedback, they say some say it's okay, some say it's hard. Yeah, so I think it's just gonna get harder. But I don't know what's wrong with it. Because if you do a A-level paper from 2010, 2008, right? They ask you, I think you all do now, you all can still get like, it's that easier. Last time's paper, you all were born at the wrong time. Even I was born at the wrong time, so my year started to get harder already, 2018. That's the reality, though. Standard has increased. Right. But that was 1 year before you guys, when COVID was actually still a thing. Yeah, then back then they removed one topic. This year they added one.
I don't know what to me, but is it that?
But there are some not say weaker at, but like your content you just feel like not there yet. Because that's all I want to know, right? So that I can tell you what topic to work on first. Yeah. Because for Cheryl and Gemma, right, they joined a bit earlier, so I'm not as worried about that. But of course, you'll still go back and do all this lah. I know the first 4 topics I didn't teach you guys. I only started with energetics with you too. Yeah. And beyond that, we did for this law. Yeah. So thinking about what to do. Yeah, okay, because you all kind of need to do some self-study because you already have a bit of knowledge. So it's not actually that hard. If I tell you guys to go and learn the next topic, Alkanes on your own, you all can't do it, it's ridiculous, too difficult. But all this we have done before, so you have a bit of inkling. No, it's fine, fine. You all don't watch lectures, it's fine. Right? No, don't, honestly, even last time lectures confuse me also. Because the way lectures teach is very general. They don't go into the question one. Last time I also do the same. A lot of the chem stuff I learned is like wrong one, but I try to like, I don't know. It's lectures are bad. So I tell you guys, I teach you all from scratch. Yeah. Yeah. Okay, never mind. Test is test. Because yeah, that's why a few quite a few students also need to take some sort of like advanced tests, because they're advanced. But that's why that test, right? I can't really prepare you guys with this. You all must go and do all your studying yourself. I'll do the tutorial and all that. Which and also I need to check lah. So you can always bring every lesson. I need to check with you guys. So that's what we need to do for these 2 months. Quite tough lah. Okay, since we didn't do well for promos. Yeah. As for when I'm going to see you guys for consult, you all saw Ita just now for that consult, right? Okay. But what we're going to be doing instead, because he went through, how does he go through? He go through the questions itself, is it? You see the answers. What we're going to do, I'm going to print the paper blank for you guys. You're going to do it in class. Break down in class. Because very better. Okay, that's what I'll do. That's why it's going to be a legit session. Yeah. So as much as possible, we try to do that soon. But I heard you guys are busy next week, right? Yeah. Because we still need to complete our lessons. We still need to complete 6 lessons this one week, which is a bit tough. That one is for like the December lessons. I'll record it and then send to some of you guys for overseas. Yeah, but then beyond that, this month try to have face-to-face lessons. Zoom lessons I don't like. We got a few questions to settle. Okay. As long as we settle these questions, then we will be done for today already. Okay. Very good. Are you okay? The specs.
You see, right, weeks ago, right?
What?
We had this exact same problem. Like,
When you wear specs, you get.
then,
Is your degree correct? Okay.
yeah,
If you want to go now, just go and rest because the rest is recorded. Not to worry. Yeah, you go just leave whenever you want. Yeah, the lesson is recorded. You should go back and rest first. Okay. Yeah, okay, whenever it's here, just leave. Okay, so, okay, guys, let's take a look at question 4, level up question 4. Okay, this one will cover quite a bit of the concepts that we went through last week also. Okay. Not last week, okay, lah. Okay, question 4, I need you guys to read the question. Okay, draw the skeletal structure and try part 1 and 2. There's paper at the back of the class. Okay, part 1 and part 2 first. Okay, we do one thing at a time. Question 4, level up. Basically the multiple of the products. Yeah, this guy can only form two products. So. To rotate plane polarized light, you must have a chiral carbon and no symmetry. Yes.
Maybe. Four. One, two, three.
Dimethyl butene.
Yeah, go with it. You go with that. Maybe just here.
So that's being offered.
Maybe the moon has the fire. And with that 1 hour, then we went to sleep.
I think that's what.
Then we had,
Hour.
then we had, breakfast and we were flying.
How we know one is safe? No, no, no. Why 1 hour only? Then you still go to school next day. The logical thing to do is go and party. Don't go school next day lah. School. What's that? But wait, the school brought your fly. But I think it looks damn bad. Like you fly the thing. Like, oh, it's fun. Isn't it there for like 5 seconds? Then you like, okay, come down. Right. But I think sleep is better than I fly, not gonna lie. No care, but I think sleep more important. For you can even pick yourself. Oh.
It has been a fast and eventful faster. Yeah,
I think that's why you're sick. You're a math today.
Yesterday,
Wait, it's just you who slept 1 hour. You're still alive. That's still normal. What the? I sleep anything less than 7, right? I'll look like a dead man walking. Serious. Cannot. Anything less than 7, I'll be angsty for like a few hours. Yeah, legit. That's a dream. 9%, so I sleep at 3. I want to sleep at like 10, right? Cannot. I'll just like, it's too early. We're gonna watch a show, go do something.
then after assembly.
You can do the 2 thing. You know, because this is how I always wake up at 4 a.m. how to get straight A's for waking up at 4 a.m. You can start making the beat.
Every day. I was getting 9:30, then I woke up at 4 a.m. And I was studying all the way to school. And then I come home from school because I'm tired. And after I get tired, I just sleep. Yeah, it's fine.
Guys, I think we know the secret now.
Oh, okay, this is okay.
You're crazy. Why? How do you wake up before the sun rises? I can't do that.
It's very quiet.
But the night is quiet too. I can stay up at night and it's quiet also. So that means you wake up at 4:30, the sun is not up, it's depressing. You're like there. You sit at the table, then you try your tissue.
People,
You're crazy.
when you don't get night,
I feel like mornings got vibes, but I just can't do it. I just can't wake up.
flat when the sun
Yeah.
comes. On the weekends, I do test my discomfort.
What? Weekends I sleep in well, I think I'm a bad example.
Oh, sorry.
Okay, guys, we go over part 1 first. You just draw the 2 structures. Okay. Okay, we continue the mechanism in a bit. Okay, guys, you see this, you must determine some sort of center point or symmetry, right? Okay, is there symmetry in this compound?
Yeah.
Okay, I'm trying to determine all the unique compounds. So I'm going to split this into 2 first. Okay, so you only look at one side, one half, right? Okay, then the next thing is there any center points, right, that you can identify on the one half of the structure? Any center points where they branch up in the same amount? Yes, right. This is a center point. What is a center point? A center point is where when you go into both directions, they are the same half. That's why it's called a center, right? Okay, so in other words, over here, we are looking at how many structures? Any sum here? Yes, right? But the center point, you don't want to go here again. This is the same as 1A. You can see they are both the same half. Okay, then here is the second structure. Do you go anywhere beyond the line? No. Okay, that's why we have 2 structures. So our structure here, okay, let me draw structure 1 first. This is bromine or chlorine. Yeah, bromine. Okay, so bromine over here, attach it to the first carbon and the second carbon. Can see that? But they want you to identify who's X and Y properly. So Y is the only one that's chiral. Okay, Y and Z. Okay, who's Y? Okay, Y should be the first one actually. Z is the second one. Okay, why? Like, wait, because Y is to rotate plane polarized line, you must fulfill 2 criteria. What are the 2 criteria? 4 different groups, chiral, and not symmetrical. Are any of them symmetrical? No, right? Okay, because it's not, there's a bromine. Okay, this is not symmetrical, and yet there is a chiral center which is here. CH3, CH2Br, H, and then the 4th group, 4 different groups. Can see that? Is this carbon chiral? Remember, always look at the Y conversion. This is not chiral because 2 are the same groups. You see that? Okay, this one chiral or not? This carbon also has 2 same groups. This carbon has 2 same groups. So this one no chiral center, it is not, cannot rotate plane polarized. You see that? Yeah, okay. Once we're done with that, right? Okay, we can try our part 2 as well. Yes.
I thought we
3 or 3 carbons. Yeah, okay. We look at the right to the left. Butane is 4 carbons, right? 2, 3 dimethyl. So 1, 2, 3, 2 and 3. 1, 2, 3. This is CH3. Yes. CH, okay, because skeletal formula, right? We don't write the C. The C is represented by any points or any bands. Yeah, okay, you want to write CH3, can is can, but you don't actually need that. Okay. Okay, in the meantime, they want you to draw compound Y for the mechanism in part 2. So just be very sure that your substitution is on the correct spot. No, did they ask for it? Oh yeah, they did. Okay, they did ask for the ratio. Okay, so what's the ratio of y to z? Anyone? Yes. Okay, you see first y substitutes on carbon 1. Go and find all the ones. So count the number of hydrogen on all the ones. How many do we have? 3, 6, right? Okay, you don't have to care about the other half, because the other half is the same as this. Right? You want to count the whole thing also can. 3, 6, 9, 12 also can. Okay, so you want to count the whole thing. Let's do it now. 3, 6, 9, 12. Okay, carbon 2, which is structure Z. How many hydrogens are there on carbon 2? Carbon 2 only has one hydrogen, but how many carbon 2s are there? Another one here, right? So there's 1, 2 long. So 12 is to 2, the same thing as 6 is to 1. Can you see that? So that's why I didn't have to count the other side, because the other side is the same. The ratio is going to end up the same as well. So you just have to look at one side, right? And then just count. This is 3 plus 3, 6. So 6 is 2, just 1 hydrogen. You see that? Okay, so it's all about counting the number of hydrogens, okay, which is what I've been doing so far. Alright. Anyone lost? Okay, let me explain again. I'll draw bigger. Okay, to draw compound Y is substituted on the first carbon. So identify all the first carbons. Okay, this is carbon 1, right? This is carbon 2. But we know this is carbon 1A, correct? Now, how about this carbon here? This is a duplicate of what? 2. So it becomes 2A. This one is a duplicate of what? 1, and basically they are the same, right? So it's all duplicates of carbon 1. Can you see that? So to find structure 1 now, which is compound Y, what is the ratio? How many hydrogens can you get carbon structure 1? Okay, 3, 6, 9, 12. All the ones add up. That's how I want you to label very nicely. 3, 6, 9, 12. Yes. 4 carbon ones. Each carbon 1 got 3 hydrogens, so 12 in total. Can you see that? Okay, next, carbon 2. Carbon 2, how many hydrogens are there in total? Okay, 2. Because one carbon 2 only has 1 hydrogen. So 1, 2. Simplify it, 6 is 1. Number everything. Label all the duplicates. Okay. Right. So no, don't say it. Don't say it. And like this counting 3, 6, 9, 12, all this counting, right, only appears in this topic. Okay, there's no more other ratio stuff really from now on. Okay, other than that, okay, just make sure you go draw all your initiation, propagation, termination. They are only asking for structure Y, so you must draw out structure Y as the final product, right? Okay, once done the mechanism, I will go through, right? Yeah. How about we- Z, right? It's formed by a substituting only carbon. Yeah. So count all the 2's hydrogens. Carbon 2 only has 1 hydrogen. 1 plus 1. how we do this one. Or like the molecular formula. Or you want to draw the mechanism, then okay, try to draw the skeletal formula. Yeah, draw the skeletal formula. Yeah, it's possible. Yeah, you want to write out the formula in the words are very difficult. So draw this. Then just draw the skeletal formula in your mechanism. They ask for why. Next. Yeah, I'll start to draw the answer for part 2. Maybe we move on to part 3. Think carbon. Because we mentioned you cannot kiss the carbon. They need to maintain this one. Yeah. Yeah, carbon. Yeah, just bring them together. So the goal is now you're kissing. Yeah, kissing each other. No. Because you see, right? Sorry. Small. Draw. One move, right? Yeah, I really I don't see as well. I don't know. I just try to read so that you all can see. Okay, to draw this, I know it looks very complicated, right? Okay, but just draw two side by side and then put one line over there. Because can you all see, right? That this dot over here and this dot is basically can be on any carbon one. So let me just put them side by side. Let me put the dot here. Correct also, right? It's the same radical. Then I'll just take these two and just draw one line in between. Anyway. Yeah. Yes, two dots must come up with a new line, a new bond. That's what we talked about just now. So you must avoid the scenario where they end up kissing each other. Because when the two carbons kiss each other, you will reduce the carbons by one unknowingly, which is not what we want. We're just adding both of them together. Okay, any issues with the free radical stuff? Okay, we will go through our part 3, part 4 together. Okay, then we can end off for today already. Okay, so they asked us to explain the difference in the relative rates. Okay, this is the one part that we went through last lesson as well. Okay, so you take a look at this. Between primary, secondary, and tertiary hydrogens, from our own knowledge, which one is the most reactive? In tertiary, we went through okay, all our predictions that we did just now, 12 is to 2, 6 is to 1. All this is based on one assumption. Can you remember what that assumption is? We can count so comfortably, right? Because we assume that the hydrogen atoms are well, again, you can remember the last week's idea. We can comfortably count the different types of hydrogens because they have a what chance of substituting. Okay, and not say 100%, but hydrogen atoms have equal chance of reacting. Yes, okay, it doesn't matter whether primary, secondary, or tertiary. We can count so comfortably, right? Because we assume all the hydrogen types have the same chance of reacting. But in actual fact, different types of hydrogens will react differently. As you can see here, it fits our knowledge that we learned. We have learned last week that tertiary is the most reactive hydrogen. As you can see here, the chances of tertiary reacting is super high, 20. Okay, you can see that? So in other words, the first part of this question, part 3, asks us to explain the difference. Why is it that primary is the least reactive, tertiary is the most reactive? Okay, so as you can see here, our actual ratio, right, doesn't follow this assumption. It is wrong. They don't actually have an equal chance of reacting, right? Now, have we ever learned why different types of hydrogen react differently? Did I teach you guys different rates of hydrogen? No, we never learned that. That's why there's another perspective that we can look at instead, right? What do we look at instead? We looked at the radical, right? Okay, you can see we mentioned last lesson that different types of hydrogens will also form radicals, correct? So if you look at this particular question, okay, my bad. Let me rephrase again. I'm saying that the product, right, can form the radical. So what I'm trying to say is this. Okay, if you look at this particular compound, when I form structure Y, right, before I form structure Y, is there something in between? What's the radical that is used to form structure Y? This radical over here, right? So it's not an H radical. I'm not saying I'm forming a H radical. H radical doesn't exist. But I'm saying that the hydrogen that was once on the first carbon here can break already and form this radical. That's what I'm trying to say. Does that make sense? Okay, I don't form a H radical. That's not what I'm trying to do here. So in other words, okay, let's look at erase this part. Let's look at the other structure, which is compound Z. Okay, this is the radical used to form structure Y. But to form structure Z, right, where's the hydrogen that I'm discussing? The second, yes. That means where's the radical? Also on the second, right? That's the radical used to form structure Z. So remember, guys, to explain this kind of questions, you don't talk about hydrogen's reactivity. In fact, you talk about the radicals that are formed after the hydrogen breaks apart. So guys, this hydrogen here is what type of hydrogen? Okay, this carbon here, how many other carbons are bonded to it? Okay, this carbon is only bonded to one other carbon. So it's considered which one? It is a primary hydrogen and a primary carbon. You can see that. Now this one is the one. This hydrogen is bonded to this carbon. How many other carbons is it bonded to? 1, 2, 3. So this is a tertiary hydrogen. In other words, likewise, this is also known as a primary radical. And this forms a tertiary radical exactly. Okay, so from our own knowledge, we knew that tertiary radicals are more reactive. But can you remember the explanation? All these alkyl groups that you're bonded to, do they have some sort of special effect? Okay, let's just go through this one more time. Okay, from this question, it is told to us that who is more likely to form? Tertiary or primary? Tertiary is more likely to form than primary because that's what the question said, right? Okay, we're supposed to explain this. Why is tertiary? Okay, tertiary radical is more likely to form. Something that is more likely to form is okay. We are skipping a few steps. You're not wrong. Okay, it's correct, but we are skipping a few steps. More stable. Yes, the tertiary radical is more stable. Remember, anything more likely to form is more stable. Why is it more stable? Fundamentally, radicals are what? Stable or unstable stuff? Yes, fundamentally, radicals are unstable because let's not compare first. Radicals fundamentally they are okay, good. Okay, so radicals are electron deficient. That's why they are so unstable, right? They're very desperate. They want a partner, very thirsty, right? Okay, so in other words, if the tertiary radical is more stable, it means the tertiary radical is what is it? Less unstable means more stable, right? Same thing. That means it's less electron deficient. Can you see that? Something that's more stable isn't as thirsty, right? Isn't as desperate. So in other words, it's less deprived. Less electron deficient. Why is he less electron deficient? What's the difference between a tertiary radical and a primary radical? Tertiary radical has more alkyl groups, which are, how do you describe alkyl groups? What special effect do they have? Remember, alkyl groups are like your sugar daddies, they will give you money, they can make you feel less poor, right? So if more people give more sugar daddies give you money, the better, the less poor you are. So again, you must meet the whole package. Tertiary radicals have more electron donating alkyl groups. Please highlight these 4 words. It's a full package, right? Cannot be separated. And because it has more electron donating alkyl groups than the primary radical, it is less electron deficient, is more stable, more likely to form. Okay, that's why tertiary has the highest chance. Okay, for this question, they asked us to explain in general primary, secondary, and tertiary. So you can just say, okay, tertiary radicals is more than your secondary or primary. Okay, never mind. Okay, all right, like that also can. What I'm just more interested, I'm more concerned, right, with your understanding. I know this question is asking to compare primary, secondary, and tertiary. Never mind, we do just in context of this question, just do tertiary and primary. Okay, you want to modify your own answer, you do it in your own time. Okay, how to go and change it to tertiary, secondary, and primary. That one you do yourself. Okay, but as of right now, this is the thing that we went through. Remember the flow. I know it's quite a bit to unpack. Okay, with that. So yeah. In other words, guys, okay, that's the part 3 explanation. We need to finish up part 4, and then that's the full question already. Okay, for compounds Y and Z, you erase the mechanism here. We just now determined that the ratio is 6:1. Okay, we all finish with part 3. Okay, we'll copy first. Okay, think about part 4 for those who are done. They want you to calculate the real ratio, the actual ratio, not what we predicted just now. What you actually see, right, when you do the experiment. Okay? Yeah, we are supposed to use these numbers. Remember, this 1, 8, and 20, right, is only for the hydrogen, but we are now looking at the product. The product isn't just made out of hydrogen, it's made out of all the other stuff as well. So that's why we need to account for that. Yeah, come, let's take a look first. Okay, our just now, right, our answer 6:1. Is that the real ratio? That is the what ratio? The predicted or expected ratio, right? This is what you expected, you predicted, but that, of course, that's not true. Okay, we're supposed to find the actual ratio. So perhaps I want you guys to write down the predicted first again, and then I want now to find the actual ratio. Okay, so we are definitely not going to get 6:1. Okay, we are definitely going to get something different, right? So again, guys, we have already identified the reasoning behind all this. Compound Y is what type of hydrogen? They gave us 3 types. Which hydrogen is this? Okay, good. This guy, compound Y, came from this radical. It's a primary radical, so the rate of a primary radical very, very low, 1. How do we combine both the hydrogens plus rate, right, and our predicted ratio? What should we plus times? Okay, you want to account for both, right? You will learn this in math soon, probability. You want both like chances, right, to come together, you must multiply. Okay, so just know, okay, just multiply. Okay, as for why you multiply, right, Ita will explain better. Okay, now more math. Okay, but in other words, I just need you all to multiply together. No such thing as plus the ratios. No. Okay. So 6 times 1 is just 6, right? Okay, guys, then what's the compound Z? Compound Z came from a what radical? Tertiary radical. Tertiary radical has a tertiary hydrogen. You see, they're all linked together. Tertiary hydrogen has what chance? You're gonna boost your chance by 20 times. Can see that, guys? Both of them are playing their own part. Your prediction plus the hydrogen. You have to account for both. They will compound each other. That's why must times. Okay, small amount. Okay, it's not gonna help much. But this one is gonna boost it by 20 times. So guys, now my new ratio is 6:20. You're going to simplify it, go ahead. Okay, so simplification is 3:15. Answer. Divide by 2 is 10. What am I doing? 25 just. Okay, 10. So usually just now what we've been doing the whole lesson, right, is to find the predicted ratio. The prediction one is for you all to go and count. You can just simply count because we assume all of them have equal chance of reacting. We never care whether they're primary hydrogen or secondary hydrogen. We just find all the unique products. But then sometimes if they ask you to find actual ratio, they have to give you this chart. You don't have to memorize this. This one they'll give you. Then you need to find actual ratio. Just multiply both together. Oh, got it? Okay, so at the end of the day, your Z actually has a higher chance of forming it. Okay, not your Y. All good? Okay, so with that said, again, that's it for today. Right? Okay, so again, some of you guys struggle with this. It's normal. Okay, this alkanes thing at the start is difficult one. But once y'all get the hang of it, I can guarantee it's actually quite fun. It's easy. I was once there as well. Alkanes, I don't know shit. Don't know what the school teach me. But then right, after I figured it out already, which you guys will do in time, it'll be fine. Okay, so I tell you what, okay, you want to figure it out faster, right? I'm going to redo all the questions that we did today. Yeah, legit, do one more time. It'll be easier one. As I said, it will not be harder. Okay, it will be easier than what you all just did. Okay, you already did the first step. Okay, so can right? Okay, so that's it for today. Next week we're gonna start on our keys. Preferably, right? I actually want to see you guys 2 times if possible. Because I just want to do earrings. Then next year you don't suffer so much. Yeah. Okay, can we do Monday, Tuesday? I have to check the rest out. Okay, if you 3 can, right, I'll text in the group also. Sorry? Because Monday I can do any day. What are y'all doing in school? Yeah. Wow, as I said, lectures useless, don't go. Serious. You're wasting your own time.